Good morning, everybody, and welcome to episode 43. Apologies for that typo in the intro card, just so that it's calibrating single L, not double L. But anyways, welcome to episode 43. Today we'll be talking about swapping your dual extruders. As you guys know, method uses two extruders, one for material, one for support. I'll be running through basically the whole demo of how to change the extruders and then how to calibrate them. The process, if you're familiar with the method, well, you might know there's already a target in place for the printer to automatically calibrate the extruders. In previous generations, both of MakerBots, in more sort of standard 3D printers, the process is taken, over by the user. It's a manual process where you usually slide a piece of paper underneath the extruders and try to figure out if it's, the correct tightness against the build plate or not. With method, that process is completely automated for both extruders. So the printer itself is going to be aiming towards the target. I'll show you the target in a second. And we'll, by poking around that target, we'll actually find out where are the two extruder nozzles located in X and Y directions, and of course the Z offset, in order to essentially calibrate the distance between them. Why is that important? Because calibrating the distance between both extruders will allow you to have better precision on your parts, especially when using the soluble supports, right? As you know, when you're using the soluble supports, you're talking about two extruder heads, because of the fact that we're using two extruders, right, that are going to be playing with one another. And by playing, I mean they'll be relying on the position of the previous extruder in order to know where to deposit the material next, right? So if there's any misalignment there, you might see issues with your parts, essentially causing defects or failed prints. So with that, I'm going to just take you guys through the setup that I've got right here. As you can see, two cameras as usual. We've got the Method X with the clean air system on top. I'll go over through the removal process as well. I've got a few extruders here, so I will talk about all of them. I have basically the full layout and lineup, which I'm really spoiled about. But extruder 1, extruder 2, the Labs extruder, the 1C, and the printer itself that is set up with the 1XA and 2XA extruders, right? And just to confirm, as always, Alejandro's on the back end gathering all of your guys' questions. If you have any questions live now, you can comment them on the section. I think it's the right-hand section of your window, and we'll be answering them as we go. Otherwise, if you're watching the recording, feel free to ask questions on the comment section down below, and we'll be sure to get back to you as soon as we see those messages. So let me toggle first to my secondary view so that you guys can see the extruders that are set up in my printer. As I said before, this is a Method X. Apologies, street noise. Anyways, the Method X printer, it's actually got the clean air unit on top of it. The clean air, we've talked about it in the past. I'm sure you guys have heard about it, but it's essentially a filter, a HEPA filter plus a carbon filter that adds another layer of protection to your printer, and that's protection against any volatile compounds, right? It's essentially forcing air through it, capturing all of the air that comes out of the printer, potentially all of the particles as well, filtering it out through a HEPA filter and a carbon filter, and ensuring that the air that comes out of the printer is as pristine, as sort of safe as it could be. Especially great and useful for smaller spaces like an office setup, what I've got here with my little studio place. So great overall, but that's a whole other topic, right? Right now on the printer itself, I've got loaded model 1XA extruder, that's my model extruder, and 2XA extruder, that's my support extruder. These two extruders are only compatible with the Method X or the Method X Carbon Fiber Edition. They are meant to be used specifically with, in the case of 1XA, it's going to run with mainly with ABS. That's kind of like the default setting. But you can use it with any of the high temperature thermoplastics that we have available. So that includes ABS, ASA, polycarbonate, and the like. And extruder 2XA is going to be our SR30 support extruder, right? So SR30, proprietary material from Stratasys, we are really lucky to be using it. And the big thing or deal about it is that it's actually soluble in water plus an agent. So great to be able to print soluble supports. We had the webinar, well, actually the chats last week on it, that essentially, It allows you to print soluble supports with ABS, which is kind of really hard to do if you're having sort of a standard, more basic desktop 3D printer. But anyways, 1XA and 2XA. So I'm going to get started with the process. I would say, as a good rule of thumb, it's always great to unload the material first as you're trying to swap extruders. So what I'm going to do today is, and I'll bring the extruders here to the camera, the second camera. But what I'm going to do is I'm going to swap out the default extruders that come with the Method X, so 1XA and 2XA, and I'm going to change them for the 1 and 2 extruders. The 1 and 2 extruders, I'll talk about them in a second, but it's essentially the extruders that come by default with the regular method, so the standard method, and they are dedicated to lower temperature polymers like PLA, TOF, nylon, in the case of the extruder number 1, here, extruder 1. And in the case of extruder 2, it's going to be dedicated for PVA. That's another water-soluble filament. This is intended to be entirely water-soluble, so it doesn't need, PVA doesn't need any sort of additional, any additive on the water to be dissolved. So also a great material to use. However, PVA, it's mostly compatible with lower temperature filaments, so you won't be able to be printing with to print with PVA and ABS, right? That's where SR30 comes in. But PVA and PLA, great combination. Nylon as well. In any case, I'll be changing 1XA to 1 and 2XA to 2, right? So that's one other thing about the method, and I'll talk about it in a second. First, I'll start the offloading process. So I'll go here and click Material. And within Material, I'll hit Unload in ABS. And as you can see here in my interface, the extruder is going to start to heat up, right? It's going to heat up the extruder so that it melts enough of the plastic so that it can basically roll back. And if you're seeing here on my other view, and I can toggle between both of them, so kind of getting fancy here, but my ABS material is stored here in material bay number 1. I have dedicated drawers for each material. So in this case, bay number 1 is for the model material, and bay number 2 is for the support material. This is the white SR30 material. I'm offloading first ABS. So I've got it here on my bay. It's going to first heat up, as I was saying, the extruder. Once it reaches 245 degrees Celsius, it'll let me know to pull back on the filament, right? So I'm going to essentially re-spool the filament. Unlike what happens when you're loading the filament, the offloading is not an automatic process. You actually have to help the printer. There's no reverse, essentially. That's what I'm saying. No reverse gear in the loading process itself, right? It can load the material in automatically, but in order to unload it, you actually have to re-spool it manually. So right now, it's already telling me that the material is going to be backing out of the extruder. And in just a second, the printer will actually prompt me to re-spool the material back into the spool, right? So giving it a few more seconds, which is another interesting thing, right? I don't think, or at least in my experience, I don't think any other 3D printing platforms really compares to how fast and easy it is to change filaments and extruders, as my experience with the method has been. You're usually talking about a good hour between the material switching and the extruder swapping, plus the calibration. But yeah, here we go. Rewind the spool, taking the material back. I don't have to take it all the way back. That's more than enough. And I'm going to close it off. And now, as you can see in the interface here, if I toggle here on the view, it knows that the material is there, but it's not loaded, right? I'm going to go ahead and also unload SR30, just because we are going to be changing both materials at once. And while I do so, I am going to take, let me switch views once more, but I'm going to take this little metal brush. The brush itself comes with the printer, and I'm going to clean the extruder nozzles. Why I'm cleaning them? Because if I jump, well, I'll switch views in just a second, but the extruders tend to have a little bit of leftover material after you've been using them and printing with them for some time. And the metal brush actually allows you to clean them up thoroughly and remove any excess material, any little debris on them. And the time to clean that up is actually when the extruder is hot, because, well, it's melting the material, and it actually makes it fairly easy to remove the material from it. Now, I got it like sort of pristine, sparkling extruders, which are better to be, not better, but they should be this way in order to be calibrated, because any excess material on the extruder nozzle might affect and will affect the sensors on the printer and the calibration process. So in turn, you can have slight deviations on during the calibration process, which will affect your prints over time, right? Because it's essentially telling the printer that the nozzle position is not where it should be, or where it actually is. So cleaning those two nozzles up with my handy metal brush, just making sure that I'm getting all of the excess material here for both 1XA and 2XA. Now it's offloading the SR30 material. Here again, it'll tell me once more. Once it's done, it'll ask me to re-spool the material. Here we go, rewind the spool. I can do that. All set, hit done. And now for the interesting part, going into the machine and swapping the extruder. So I'm going to switch over to this view, and I'm going to be showing you the detail of the detailed view of the actual calibration process. But first, let's go ahead and swap the extruders themselves. So as I said, I'm trying to change and put in extruder, here we go, extruder 1 and extruder 2 inside of the machine. First off, I'll disconnect my clean air unit. I'll power it off, disconnect the power from the clean air as well, putting it to the side. The clean air unit itself, it's not locked mechanically to the printer, so it's just sitting there on top of the printer, just being held off by gravity. Here it's letting me know that it's not detecting the clean air unit anymore. I'll just hit OK. So as I was saying, the unit itself, it's just sitting on top of the printer. There's a gasket on top of it that creates well, essentially a seal around the printer and the top of the printer, but I can go ahead and lift it up, bring it to the side, just putting it here on the side, and now this exposes my main lead in my printer. Just tilting the camera view a little bit so you guys can see in more detail. All right, removing the lead, putting the lead to the side, moving the extruders over so that you guys can have a better view. And as you can see, I got both extruders here. They are shining red, which means they are hot, so I should be careful with them. I'll go ahead and remove the filament guide tubes here, put them to the side. And first off, I'm going to remove the latch of extruder number 1, which is 1XA. It exposes the actual number of the extruders, extruder number 1, removing the latch itself, and pulling up the extruder. That's it, right? That's all that I need to do in order to remove the extruder. I'll put the extruder 1XA to the side. Going to do the same thing for 2XA, removing the latch, opening the door, lifting up the extruder, and that's it. Got my extruder here to the side. Now, of course, taking by the two extruders that I'm replacing now, extruder 1 and extruder 2, dropping them in the relevant carriage units and mounts, closing extruder 2, closing the latch, closing extruder 1, closing the latch, and bringing back my guide tubes into the extruders themselves. That's pretty much it, right? Now my extruders are already been changed, and as you can see, the printer is detecting that the extruders have been changed, and it's going to ask me in a second to actually run the calibration process. I'm going to go ahead and drop the lid here, and I am going to be bringing you guys a little bit lower. Here we go. Calibration required, right? So it's asking me to calibrate the extruders, which I'm going to do right now. Calibrate now, begin calibration. And first off, the build plate is going to be raised up. Let me switch views again. So raising the build plate here, not all the way up, just enough to sort of get close to the extruders themselves. And then the first step is going to be to actually remove the build plate. Why? Because the target against which the extruders are going to be calibrating, and here you can see it on the interface, right? The target against which I'm going to be calibrating my extruders, it's underneath the build plate. So I'm going to open my printer here, remove the build plate, and as you guys might be familiar, the build plate on the Method is actually flexible, right? This is spring steel, so I can flex it. Let me put it against the camera. I can flex it quite a bit. The reason being that, you know, it's actually enabled me to pop out the prints once they're done. That's actually a rare feature. Usually you see build plates made out of glass. They are okay for the first layer, but I have had a great experience with the spring steel. It's just, you know, so easy to use. But in any case, my build plate, putting it to the side here on top of my sketch, and bringing you guys in to see the action happening here. Let me just position the camera before I run the calibration. So I want to get you guys as far into the printer as I can. Here we go. And I'm going to switch the view in just a second. Just let me set up the camera correctly so that you guys get a really, really detailed view of what's happening here. Here we go. Okay. And I'm going to set up a macro lens as well so that you guys can see and follow along the extruder is being calibrated. The macro lens is just allowing us to have a more detailed close-up of the calibration process, right? So I have removed the build plate. I'll just hit build plate is removed. Since these extruders had been already cleaned, I had cleaned them before. I usually do it every time that I change materials just to make it easier on me. So I'm going to go ahead and hit skip, allow the printer to reset, and that's it, right? That's all that I need to do. Now, as the calibration process begins, and I'm going to switch back to this other camera view, right? As it begins, the extruders are going to be aiming for that metallic plate that you can see on the, let me remove the macro lens, the metallic plate that you can see back in there in the machine, right? So they are going to be probing against that metal plate, trying to find the location of each extruder against that metal plate in order to determine the position between the extruders, right? So here we go. So you can see it's just going to be probing. Let me move it a little bit so maybe I get a little bit less flare happening. Still too much. Let's see what we can do. Getting rid of, sorry, it's kind of shaky, I know. All right, this should do it. And then if I move to the right hand side, okay. Can I get you guys further in? I'm going to switch views for a second, just while I'll leave the printer running here. Here we go. And in the meantime, feel free to ask any questions that you might have of the calibration process itself. I'm going to set up the camera first, again with the macro lens, just to see if we can get a little bit closer into the chamber. Oop. Just gotta be careful here. All right. Let's see. Yeah, much better. Here we go. Now check this out. Awesome. So as I was saying here, you know, what's happening is you can see the nozzle probing against that steel plate. The steel plate itself, it's a machine steel plate that, you know, acts as a reference for the nozzles. It's going to be probing in 2 axes, in X first, slowly moving the extruder back and forth in order to find the exact location of that extruder against that particular target, right? The target is the same for both extruders. So right now it's calibrating the material extruder, the left-hand side extruder. And in just a second, once it's done with the first extruder, it's going to switch over to extruder number 2 and run the same calibration process, right? But I love that shot. I love like how tight we can get. Let's see. It's done with the first extruder. It's going to go back to the side, switch over to the second extruder. Here we go. And now you can see, right? The first extruder is now not visible on the camera. I can rotate it a little bit if you guys want to see it. But it's now calibrating that second extruder here against that same target, right? Here we go. A little bit bright. But let me see if I can get rid of some of that glare just by moving the camera around. Not really. I'll let it run for now. But you can see how tight it gets, right? How precise the camera, sorry, not the camera, how precise the machine is actually just probing against the target and trying to find out the exact location of the nozzle. And here's where the importance of cleaning the nozzle comes in, because it's not aiming against the very tip of the nozzle, it's actually aiming towards that cylinder around, or the main cylinder of the nozzle itself, right? You can see how it goes up and down against the wider cylinder of the nozzle. That's why it's so important to keep those nozzles really clean, to clean them up before the calibration process begins, in order to have essentially a pristine target and reference for the printer to target up against. It's almost done now. It's calibrating now the y-axis. So as I said before, it's going to calibrate one axis first, the second one later for each extruder. And once both extruders have been calibrated, it's going to switch over and calibrate against the build plate. So it's going to ask me to place the build plate again inside of the machine, and then that will finalize the calibration process. But all in all, there's no real user intervention outside of removing the build plate, right? And that's one of the cool things I think about the platform itself, that there's no real everything, or as much as possible, we try to automate as many processes as we can, just to make sure that both, it's easier for the user, but at the same time, it's just a more precise way of measuring, because there's no human error involved in this case, right? We are not. Here we go, that's done. But I was saying, we are not relying on the user to create a dimension between both nozzles and then figure out what's the offset, but rather the printer itself is measuring that out for you and then figuring out the location, right? So that in turn reduces the amount of failure points within the process and enables you to have a more precisely calibrated machine. So now that it's done, I'm going to remove the camera here, bring it out. Maybe switch views so that you guys don't get too dizzy. All right, I'm going to place a camera to the side just for a second, and it's asking me to just place the build plate. Going to go ahead and do that. As you know, or maybe you guys don't know, but there are magnets that actually keep the build plate in place. Since as I said before, the build plate is actually spring steel. There are, I think, 12 magnets located in the actual gantry of the build plate that help secure the build plate here. There we go, just snaps into place. That's it, confirming that the build plate is installed. The printer runs a final calibration, or poking against the build plate itself, used to recognize the offset between the build plate and the target that it was referencing before. And that's it. It just confirms that the calibration was successful, right? Lets me know that everything is running okay. And that's pretty much it, right? That's the whole process. So it took me, it's now 11:23. We got started at 11:20. Took me like 20 minutes to complete the process. I would just now proceed to load material here on the printer. I'm leaving the camera view here. It looks kind of impressive. Maybe bring it a little bit closer so you guys can see the extruders, and in case that I want to bring you guys in again. But that's pretty much it. So about 20 minutes to switch extruders, calibrate them, and essentially be ready to load the material now. So pretty straightforward process. I think that it's one of the simplest ones that I have experienced so far. I've tried a few different alternatives and platforms, and none of them are really super intuitive or straightforward to follow. But in Method's case, it's just, for me, it's of course a pleasure to work. So I'm going to start jumping into the questions while I have the printer here. And if you have any questions regarding the calibration process, the extruders themselves, or the printer, let me know. But in the meantime, let's see what we got here. So what's the benefit of having two extruders? Well, the main benefit, as I said initially, and I'm going to switch to, let me raise this camera view a little bit so that we can see and keep the focus on the extruders themselves. So the main benefit of the two extruders is that we are able to print with a material compound and a support compound. The support material is going to enable us to have soluble supports, and in turn have the possibility of creating much more complex geometries that can have soluble supports. And once they are done, you just dissolve, remove the supports, and have a fairly complex part on your hands. Are dual extruders faster? Technically, no, I wouldn't say that, because if you can imagine, the parts that are being printed on the machine, every time, and I have one right here, so every time that I'm going to be switching, and the printer is going to be switching between materials, and that happens for every layer, right? Every time that the printer switches, there's a little bit of delay that happens between printing with the support material and printing with the main material. So that's kind of like the downside of printing with two materials. On the one hand, you can create much more complex parts. You can have soluble supports that dissolve after they've been printed, once you dunk it in the water. But on the other hand, it does increase your print times, quite a little bit. So depending on the type of part that you're trying to print, you'll have to figure out if you need the dual extrusion or not. And then even within the dual extrusion, what type of supports do you want to be using in order to maximize or actually minimize the printing time on your machine. Can you 3D print with two colors using dual extruders? Well, technically, right, no. But it's not, and I know what you mean. It's that's something that we have seen in the past. Previously, we supported that with the 2X model of MakerBot. It's not something that we saw a lot of value moving forward. You can switch the colors of the extrusion while you're printing, but I would say that overall it's just better. The printer itself is tailor-made for for you to create more complex parts, more technical parts. If you wanted to paint those parts and finish them up, you can certainly do that. But I would say that switching colors or having two available colors in a single part is more of an aesthetic component, which is not something that we necessarily want to focus on, generally speaking. Like, we'll give you very complex parts, right? This is actually a print on the sketch. But the goal is not to have the aesthetic qualities come from the printer, but if you needed them to be there, to come from a post-processing process. So you sand them, you paint the part, and that's where the color comes in. Are extruder nozzles universal? If not, what size nozzle is best for 3D printing? They are not between different platforms, right? So if you think about other brands, they'll have the other types of nozzles. In the case of MakerBot, we have 400 nanometer, 400 microns. Sorry, 400 microns. For the extruder nozzles. They are universal across all of our extruders, so it doesn't really matter if you have a Labs extruder, a 1C extruder. They are all going to be 400 microns, and they will share the exact same nozzle size and nozzle diameter. So you can switch nozzles between them if they have the ability to do so. So for example, in the case of the Labs extruder and the 1C extruder, you can remove the nozzle, and that's another topic I think that we should do at some point as well. But you can remove the nozzle, replace it, and that generally tends to solve any particular issues. If you're having issues with clogging in your extruder, it might have to do with the type of filament that you have been using, and just by changing the nozzle itself, it's an easy way to bring a whole new, reset the life of your extruder. Does layer height influence the strength of my 3D prints? It does to some extent. I've seen people trying to print with a layer height of 100 microns. It's not going to necessarily increase the strength of your parts. I would say material is definitely a much more important and impactful element. Also, the density of your parts, that's way more important, right? So if you're printing like with MakerBot Print, you can print solid parts. We have a slicing setting to create solid parts. That's going to dramatically increase the strength of your parts. The layer height itself, you can toggle it. We usually default to 200 microns. If you raise it up, you're going to be sacrificing a lot of time for marginal returns in the strength of the part, right? So it's not something that I would do. I would default to either the infill settings, the number of walls themselves, and of course the material, which is going to have the most impact over the strength of your parts. Do hot end nozzles need to be replaced? They don't need to, but as I was saying here, and let me bring it to the secondary camera. So they don't need to here, but you can definitely do that, right? In the case of the Labs extruder, let me bring in my handy dandy macro lens. Here we go. So in the case of the Labs extruder, you can see here, there is a set screw. Let me bring it, there we go. So there is a set screw holding the hot end nozzle into place. You can remove that screw and then change the nozzle itself. I don't have a nozzle, do I? No. But it actually enables you to sort of reset the life of your extruder. If you're using, like I have, in this case, I have been using a polycarbonate material with this extruder, with the Labs extruder. And after a number of hours, let's say after 500 hours printing with it, I can see a little bit of issues with the nozzle itself happening. And that's a great thing about the Labs nozzle, right? So it's essentially allowing you, and it comes with another set of hot end on the nozzle, which you can just swap out, replace, and all of a sudden you have a brand new extruder, almost brand new, right, to work with. So it's not something that you have to do regularly. It's certainly something that's really useful and a great way for you to reset the life on your extruders. And I think that with that, I'm going to start saying goodbye. As always, thank you guys so much for joining us today. If you have any additional questions, do let us know in the comment section down below. Otherwise, we are at we are presently, you can reach us at hello@MakerBot, my email felipe@makerbot.com, and also in social media in both Instagram and Twitter @MakerBot if you have any more questions. But as always, thank you guys for joining us today, and I'll be seeing you guys next time. Thanks. Bye.